Clearly, you can write inefficient code in any language. That's why the paper that my colleague Justin Sprague has authored here is so important. It's Yikes, Why is my SystemVerilog test bench so slow? Very good. So I'm Joe Hupsey. I'm here with my colleague. First, Justin, maybe tell me a little bit about yourself, then we'll talk about the paper.
Sure, Joe. So I've been an applications engineer at Cadence for about 10 years now. Prior to that role, I was a verification engineer for a number of years as well. At Cadence, my focus has been on SystemVerilog, UVM, and in the last few years, performance, particularly, helping those customers who are adopting SystemVerilog and UVM.
Very good. Now, what's the biggest pitfall that people go into when they're starting out coding SystemVerilog?
Sure, great question. So one of the first things that we see with new SystemVerilog and UVM users is memory usage. SystemVerilog brings the ability to create lots of dynamic items, classes, for example. And with those classes, people create lists of them, arrays, and they fill them up, they let the arrays grow, and over time those arrays build up. And they find that slows down their environment and makes memory usage go up as well. And so that's an area that we talk about a lot in the paper.
Just basically managing memory efficiently. You have to stay on top of that, essentially.
Correct. Yeah, that's something you really want to pay attention to and revisit throughout your project.
Makes sense. Now, let me come at it from a different direction. Let's say, I strictly adhere to UVM guidelines. Am I going to be perfectly safe when it comes to performance?
UVM is a great methodology, and following UVM gets you a long way to your performance goals. There's rules that you follow and guidelines that help you structure your test bench. One of the nice things about UVM, though, is it gives you a lot of flexibility, and that flexibility is really useful, as you're trying to solve your verification problem in your own unique way. With that flexibility, though, comes a lot of responsibility. And so, again, in the paper we talk about how to look at UVM and some of the things to watch out for.
Makes sense. So let's say I'm a C++ coder, or I come from the Specman E world, so I'm familiar with object-oriented and aspect-oriented techniques. What are some of the twists I need to be aware of with SystemVerilog?
So if you're a C++ user, an object-oriented coder, the first thing you're going to find is that SystemVerilog brings a lot of new advanced test bench capabilities. A good example of that is randomization. Randomization, there's lots of rules that you have to follow, and so you want to learn those rules and make sure you use them efficiently to get high performance. However, if you're an E user and you've been using Specman for a while, you've been doing randomization there as well for quite a while. And as you move to SystemVerilog and try that out, you'll find that the rules are a bit different. And so you just want to learn those rules and understand how they impact performance.
Makes sense. Well, thanks for sharing your insights, and we look forward to seeing your paper in the proceedings.
Great. Thank you very much.